Hi and welcome back. Hey, so now you can see me. All right, so welcome back. And today in our MATLAB tutorial, we are entering a whole new section. Okay, we are dealing now with operators, and this video will be relatively long. All right, because the type of operators that we'll be dealing with in this particular video is mathematical operators. All right, and I want to see all of them in just one video. So at the beginning of the course, we saw at the level of using MATLAB as a calculator, we saw some fundamental operators that all calculators use, all right? And we used it to somehow do operations with basic numbers, all right? So those basic numbers are known as scalars, all right? So in MATLAB, what we usually see is that any one by one, all right? I hope you can see that. Any one by one dimensional array is known as a scalar. All right. Any one by n or n by one dimensional array is known as a vector. Okay. So in this case, since it is one row, we have a row vector here. And in this case, since it is one column, we have a column vector. That's how they are named, right? We saw all of that. And any other one m by n such that m is greater than 1 and n is greater than 1. In this case we have a matrix. All right, so these are the three domains in which we want to see mathematical operators, and also how they interact with each other somehow. All right, so we'll focus on scalars first, which are just numbers one by one, and then we'll look at vectors. In fact, we'll look at vectors and matrices alike. All right, they are the same things, and then we'll look at the interaction between them. Good. So to start with scalars, let's create any two numbers. All right. We'll say a. Oh, my keyboard has gone to. I'm using the Japanese keyboard. All right. So let's use that. Oh, sorry, you were not even seeing what I was typing, right? So we'll say a is equal to 2. So remember that. Remember that a is 2. All right. And then we'll say b is equal to 3. All right, so let's say we have those two numbers. Okay, let me create a negative number just for fun, and let's even make it a decimal. All right, let's clear the screen here, and we'll say c is equal to 12.5 or negative 12.5. So don't cram this. These are the stuff here, all right? So no need to cram. These are the numbers right here. So we have five fundamental mathematical operators that you're supposed to know, all right? Addition, subtraction, multiplication, division, and power, all right? Exponential. How to do a number to the power of another, all right? So if I say a plus b, for example, that should be 5. Very simple, right? No need to waste time on this. This is straightforward. And then b minus a, that should give me 1. All right, or a minus b should give me minus 1. A minus b should give me minus 1. Very simple. A times b should give us our normal 6. And then what's that? Let's say b divided by a, right? That's more. Divided by a will give us 1.5. So what have we seen right now? This is the plus operator in MATLAB. If you want to add something, you use the plus. You want to subtract two things, you use the minus. You want to multiply those things, you use the star on your keyboard. All right, the star. And then here you will use left division. All right, we say left division because it is inclined towards the left. Is that right? Whoa, that's right division, man. It's right division. It's not left division, all right? Because it's inclined towards the right. Okay, good. Um, By the way, there's also something known as left division. Let me just introduce it here before we go. All right, left division is simply the opposite of right division. Okay, so we have said b divided by a, right? This will imply uh, b over a. All right, now left division is just the opposite. It will be a, okay, left division b, and this will be the same thing as this. So in the left division, here is the denominator and here is the numerator. In the in the right division, sorry, the one we know, here is the denominator and here is the numerator, while in the left division, here is the numerator and here is the denominator. They are just opposites of each other. All right, so pressing enter here, we should still get what happened. Pressing enter here, we should still get our 1.5. What happened there? All right, good. So the last thing we want to see there is 1 to the power of another. What's 3 squared? That's 9, right? So let's experiment that. It's just to say b and cap a, right? And that's 9, okay? What is 2 to the power 3? That should be something like 8, right? So let's say a exponential b. Good, and that's it. All right. So this closes the discussion with scalars. That's all you basically need to know for mathematical operators when it comes to scalars. Now, for matrices, all right, let's create two of them. A is equal to let me say Randy of you should know what Randy means by now, right? 3, and let's say the numbers vary right up to 5. We don't want a real we don't want a large gap. Whoa, did I confuse things? Okay, Randy will say 5,3. Right, so we have that. Okay, and then we have another matrix B is equals to Randy of maybe I should say 6, let's use the same 3. Okay, so this is matrix A and this is matrix B, and right here you can even see all of the elements. Good. So MATLAB uses the laws of linear algebra. All right. Unfortunately, this is not a course for matrix algebra, but you should know that when you want to add two matrices, what happens? You have to add all of the entries of the matrices element wise. So the first item will add itself to the first item to form a new first item. The second item will add itself to the second item to form. So fundamentally, if two matrices are to be added, they have to have the same size. So these two, for example, this is 3 by 3 and this has to be 3 by 3 if we have to be able to add them, so that the addition will be element by element. So it will be the first item here plus the first, then the second plus the second, then the third plus the third, and to form the new items. All right. So basically, what are we going to get here? If I say a plus b, let me store it in a variable c. All right. What are we going to get? You can see here, let's look this way. All right, you can see that this will be 4 plus 1, the first item, to give us 5. All right, then 4 plus 2, the second, to give us 6. Then 1 plus 3, the third, to give us 4, and so on. All right, it's as simple as that. This is what they call element wise operation. All right, so each element interact with each element according to the operator you've given to give a new element at the same position, okay, yielding the results of the operations between the two previous elements. All right, so this logic is the same logic when it comes to subtraction, and there is even a possibility of doing multiplication element wise and division element wise amongst matrices, which we are going to see right now. All right, but for that, I think that I'll reduce the size of those matrices, okay, so that things are let everything fit into the screen. All right, we have a let's use Randy of 5, still 5, but comma 2. Right, let's take it 2 by 2, and then b let's just take the same thing here, and B will be the same thing. All right, good. That's easier. So now let's do subtraction. What will be A minus B? Can you just pause the video and give the result right here? Very simple, right? I'm sure you guys are even experts at this. So we'll have something 4 minus 4, that's 0. Okay, 3 minus 4, that's negative 1, and 1 minus, right? So you get it. So 4 minus 4, we have 0 here. 3 minus 4, that's negative 1. What do we have here? 1 minus 4, that's negative 3. And then 3 minus 2, that's 1. All right. So that's that. And fundamentally, with matrices, you can just multiply. There's what they call matrix multiplication. All right. And matrix multiplication is not done element wise. Neither is matrix division, which would be ideally, if we say A divided by B, is ideally A times B to the negative 1. But that's not what we're talking about right now. Okay. Right now, we can also do element-wise multiplication. What does it mean? It means if we have A, all right, and we have B, we want to be able to multiply it element-wise. So we want to get the answer of 4 times 4. What will be the result? Then 3 times 4. What will be the result? Then 1 times 4, and so on, right? So for that, we will say A dot multiplication. All right. So you remember this dot stuff, right? Even in mathematics, when you use dot, there is a dot multiplication in vectors, right? Where you can just do element-wise multiplication. But that there is different because you need to add at the end of the day to have just one scalar. But well, here it is you do 4 times 4 to have a new element, then 3 times 4 to have a new element, and so on. All right. This will be element-wise multiplication. Okay, as you can see, and this dot notation is very important because it goes for almost all of the operators with which we can't normally do linear algebra, element wise operations like multiplication and division and exponential in matrices. All right, so let's see. So for A and B now, I would like to do division, right? Okay, let's first of all check our answer for multiplication. This is 4 times 4 to give us 16, as you can see. 3 times 4 to give us 12, all right. 1 times 4 to give us 4, okay, and it goes on and on. So to do division of one by the other, it will still be 8 dot, all right, divided by B, as you can see. Very simple, and it will do element-wise division. Okay, so 4 divided by 4, that's 1, all right. Maybe we'll look at it here. This is A and this is B. 4 divided by 4, that's 1. All right. 3 divided by 4, that's 0.75. And then 1 divided by 4, that's 0.25. Okay. And then 3 divided by 2, that's 1.5. As simple as that. We can also do, this one is what? Dot right division. All right. We can also do dot left division. So if I say B dot and then left division A, that should give me exactly the same answer from what we just explained, right? So you can see that, very simple. 1, okay, and we have exactly the same answer. The next thing we want to see is yeah, exponential, right? So we have A, and if I want to square, for example, all of the items inside this particular matrix, no need to stress. I will just say A dot where is that? Where is that? Exponential 2, all right? And that gives me that. Okay, I have 16, 9, 3, and then 1, all right? So this is very different from saying a square. Okay, it's not the same thing at all right? And you will see the result of a square right now. I said right now. Good. So it's very different, okay, as you can see, because a squared here is the matrix A times the matrix A. Very different, all right? While A dot to the power 2 is each item squared independently, all right? Good. So that being said, let's close our discussion with mathematical operators on arrays between arrays by matrix multiplication. To multiply two matrices properly, the way it is done in linear algebra, right? you will do A times B. Okay, for example, so that should multiply. Let's just take a particular example. It should multiply the first column of A by the first, no, the first row of A by the first column of A, right? Do a sort of vector dot product there to give us this 28 right here. So let's look at that. 4 times 4, 16, plus 3 times 4, 12 to give us what? 28, all right? And it continues like that. That is matrix multiplication. You're supposed to know that. All right, you're supposed to know that. Sorry, this is not a mathematics course. All right. Good. So that multiplies two matrices. All right. There's also a particular to look for the inverse of a particular matrix. All right. MATLAB recommends that you use the left division operator. So if I want to look for a to the negative 1, right? You know the a to the negative 1. Let me try to write it so that we all understand what we're talking about here. I mean 1 on A, right? What we know as a to the negative 1, A inverse. All right? So you use the left division to compute that. All right? So if I say A left division 1, okay, that should give me A inverse. All right? A way of saying that if you need to do A inverse and multiply it by any other matrix dimensions must agree. All right, so let's just multiply it by b. All right, or maybe create the identity matrix here, right? So let's just do identity. Any matrix multiplied by the identity matrix is the matrix itself, right? So this should be exactly A inverse. All right, so you do the inverse and then multiply it by the identity matrix. I think we saw this command of I. All right. Good. The last thing we want to see before actually closing this particular session is operations between matrices and scalars. All right, scalars have a very, very specific way of interacting with matrices. All right. Scalars will always affect all of the elements of a particular matrix simultaneously, irrespective of the mathematical operator you use. So let's say you have A, for example. All right, I want to add 2 to all of these items in A. What will I do? I will simply say A plus 2, and it will do that. All right, this is fantastic. It's simply fantastic. So it will be plus 2 plus 2 plus 2 plus 2. You can see that, right? I don't need to repeat it all the time. If I need to subtract, all right, what I will just do is A minus 2, and it will do the job. All right, if I need to multiply all of the items, all I do is A times 2. If I need to divide, all I do is A divided by 2, and it does the job quite all right, awesomely, all the time. All right, so I think that closes our discussion on mathematical operators in MATLAB, and in the next video, in the next tutorial, we shall be looking at relational operators. All right, that's to prepare us to start entering very, very interesting stuff, branching statements, ifs and whys. Okay, so see you in the next one. All right, bye bye.